So if we're just going around the x-axis, our formula for volume using the disk and washer method, we're going to have pi, then we're going to have the outer radius squared minus the inner radius squared. And it's going to be dx if we're going around the x-axis, and thickness of dy if we're going around the y-axis. So here, nice and normal x-axis, we can see the x radius is just the outer function. Sorry, the outer function is just the function that's farthest from the axis of rotation, and the inner function, the inner radius is just the one closest. So this is just going to be pi. R out is root x squared minus R in is x cubed squared dx. And of course they meet at 1. You could set them equal to each other, x cubed equals root x, and solve. But you can tell if you plug in a 1, that's going to work. So 0 to 1. And then if you solve this out, it's pi from 0 to 1 of x minus x to the 6th. So that's pi x squared over 2 minus x to the 7th over 7 from 0 to 1. So that's pi 1/2 minus 1/7. And then when you plug in 0, you don't get anything. So whatever a half minus a 7th is, what is that? That's 5/14 pi. So 5 pi over 14 should do it for that one. Now if we go to the y-axis, actually I'm going to do the line y equals 5 first, because the line y equals 5 is up here somewhere, and it looks like the x-axis, right? So it's going to still have dx, and everything's going to be in terms of x. I don't need to change the look of my original equations. So now the outer radius, the function that's farthest from the axis of rotation, is this x cubed, and that length isn't the full 5 long. It's 5 minus the function there. So my outer radius is 5 minus my function x cubed squared, and then the inner radius going from the axis of rotation to the closer function, that length there, that little piece, isn't 5 long, it's 5 minus the height of the function. So it's 5 minus root x squared dx. And I believe all they want for that is a setup. Make sure you don't forget it's still going, oh, yeah, it's still going from 0 to 1 because the x's are going from 0 to 1. So that should do it for that. Make sure you have parentheses and that just the format goes in okay. Okay, so that's that. And then if we go around the y-axis, if we go around this axis, now if we're going to use disks and washers, we have to solve these for x, because it's bizarre. So instead of saying y equals x cubed, I'm going to say x equals the cube root of y. And here, instead of saying y equals square root of x, if I solve for x, x is y squared. And our limits are going to be along the y-axis as well, but this is a 1 also from 0 to 1. So going around the y-axis, our volume is going to be pi from 0 to 1, pi times the integral from 0 to 1, and our outer radius, the one that's farthest from this axis of rotation, my picture's getting messy, but the farther function here is the cube root of y. So it's going to be the cube root of y squared, and then the inner radius is the y squared, and then square that. Now I think they just want to set up, if you want to clean this up a little bit so it's easier to type in, that's going to be y to the 2/3 minus y to the 4th dy. And that should do it.